Okay, today we're going to start section point 2 on how to find the area underneath the curve, and for right now we're going to just do estimates, and we're going to work on the first section, which is what's called lower and upper sums. So I'm going to give you a function, and we're going to start with the function that we can work with real easily. So the function is 3x minus 4, and we're only going to look at this function on the interval from 2 to 5. So step 1, always go ahead and sketch your graph. So if I plug in 2, my y value is 2. If I plug in 5, that's 15, that'll be 11. So again, not drawn to scale, but the graph looks something like this between 2 and 5. So what I'm trying to do right now is find the area underneath the curve. Okay, I know we can find the exact area of that curve because it is a trapezoid. So let's go ahead and do that first and figure out what that exact area is. So this is the area of a trapezoid, so it would be 1/2. This would be the height of the trapezoid, which is 3. This would be my first base, which is 2. And the second base, we said if I plug in 5, is 11. So this is going to be 1/2, 3 times 13. So 39 over 2 is my exact area. Okay, now what I want to do is we're going to use what's called inscribed rectangles and circumscribed rectangles. So first thing I'm going to start with is what's called an inscribed rectangle. And I'm going to tell you how wide to make the rectangles. So I'm going to tell you that the width of the rectangles, or change in x, is going to be 1. So what that means is, here's my first rectangle right here. That's the width. And when I want an inscribed rectangle, you need to hit the curve, and when you draw the rectangle straight across, the rectangle needs to be inside the curve or under the curve. If I go this way straight across, notice the rectangle's underneath. If I go across this way, notice that your rectangle is going to be over the curve. So this is going to be my first inscribed rectangle. So let's think about what the area of that rectangle is. The width is 1, and the height of this rectangle will just be f of 2. Right? It's whatever that y-coordinate is. And we're going to go ahead and do that for the next 3 rectangles. So next one. Again, notice I have to hit it on the left side to make this an inscribed. So there's my next rectangle. The width of that rectangle is 1 again. The height of this rectangle, right, this is 2, 3, 4, 5. Notice it's going to be f of 3, whatever that y-coordinate is. And go ahead and continue this pattern. There's my next rectangle again. There's my width. The height of it is going to be f of 4. So I have 3 rectangles here, and let's go ahead and punch out these numbers. So if I plug in 2, f of 2 is going to be 2. F of 3, if I plug in 3 here, is 9 minus 4, which is 5. F of 4 is, if I plug in 4 here, 12 minus 4 is going to be 8. So this is 2 plus 5 plus 8, which is 15. So this is called, we use inscribed rectangles here. Notice it is an underestimate of the actual area. Notice it's less than what we got above here, which is 39/2. So we call this also the lower sum. Okay, be careful, an inscribed is not necessarily always the same as the lower sum. Okay, it just happens for this particular function. Next, we're going to do the same thing, but this time we're going to use circumscribed rectangles. And all that means is that you want the rectangle to hit the curve above the curve or outside the function. So notice here, again, the width of the rectangle is still 1, but this time my rectangle is going to hit here. There's my first rectangle. So notice the height of that first rectangle is actually f of 3. So here's my area of the first rectangle. Width is 1, height of the rectangle is f of 3. What's my second rectangle? Width is still 1. Notice I'm going to hit it at 4, so my next height is f of 4. The width of the next one is still 1. The height of the next rectangle is going to hit at 5. So the last height is going to be f of 5. Again, notice I still have 3 rectangles that I'm working with. So let's evaluate this. So f of 3 was 5, f of 4 was 8, and f of 5, if I plug in 15 minus 4, is 11. So I have 13 plus 11, which is going to be 24. So that would be called this is an overestimate. So for this particular case, this would be an upper sum, and we're using circumscribed rectangles.